Anyway, so thanks, Paul, for the introduction. Appreciate being able to come to this audience and talk about OpenHPC. My name's Robert Wisniewski. I'm from Intel. I'm responsible for HPC software in the data center group. So as I mentioned, I'm from Intel. What I wanted to talk about today was some of the trends and challenges, and pursuant to what our previous speaker indicated, I'm also addressing one of the pain points that Earl and Steve highlighted at the beginning, focusing on the management and the ability for different sites to bring up software and to be able to run their clusters and supercomputers. What I wanted to start off with is provide a little bit of motivation about why I think some people out in the audience have their own ideas about why a common and shared stack might be good. But I want to provide some of the challenges that we identified, not only technical but ecosystem, that led us to creating and starting off this. Then I want to talk about the vision, what we're trying to accomplish with OpenHPC. I will then spend a bit of time talking about the architecture and implementation to give you a sense of what it is and where it's going. And then I will talk about Intel HPC Orchestrator, which is a supported product based on this OpenStack. And feel free if you want to ask questions as we're going along. I'm used to a lot of interactive talk, so I'm certainly happy to pause. And if something is really long, I'll queue it up for the end. So this talk is a software-focused talk, but I definitely wanted to recognize that there's a lot of hardware challenges that are going on. A lot of those are, in fact, inducing some of the software challenges we're seeing, whether it's huge amounts of scalability, both inter and intra-node, or whether it's the power challenges or reliability, as well as a lot of the heterogeneous challenges that previous speakers have identified. For sure, hardware challenges are not to be overlooked. But what I wanted to do in this talk, again, is to focus on software. So I've been in HPC now for a couple decades. And if I take a look at what we've had to produce for software over the last 2 decades, if you just take a look at classical HPC, just simulation, not a lot of these new areas, whether it's data analytics and machine learning that have come into place, there's been, even in that space alone, there's been a significant increase in terms of the complexity. If you think about what a software stack for a supercomputer was 20, 25 years ago, you maybe had an operating system or part of it, you had a compiler, and then you ran your application. But over time, there's been the need to include richer environments, Python, not just for connectivity, but in some sense we're starting to see usages of it now. There's been new models that have come along in the last 5+ years, such as uncertainty quantification, that have introduced additional complexity to the stack, as well as workflows. It's no longer your supercomputer, your cluster doesn't sit in the corner of your data center. You run a batch job on it, you get an answer back in a week. Nowadays, fortunately, as we indicated, or as Steve and Earl talked about with the ROI, we have found a way to really make HPC vital and important to a lot of ongoing companies' needs. So add to that the introduction of 2, I think, very new important areas. One of them is big data and analytics. This is something that's been going on for a long time. For 5+ years. For a long time, we've used big data in HPC, but the difference is we're trying to use big data in a different way. We're trying to perform analytics on it. So I participate in BDEC, which is the follow-on to the Exascale program that identified how we were going to get there from a software stack. This is big data at extreme scale computing, about trying to figure out how to bring these communities together. There's a lot of issues in this that are introducing complexity. We now want multi-tenancy, lots of things like that. And of course, I think one of the biggest upticks and one of the most significant changes that our field is about to see is the introduction of AI through machine learning and deep learning techniques. So what type of needs do these challenges induce? Again, it's a software-focused talk, but from a hardware point of view, I think there's a lot of value to some of the directions that are being looked at, and that is to look at doing co-design of the components. As probably a lot of people are aware, Intel no longer just produces cores. We produce networking and memory from a hardware point of view. And the value to the community, and the reason we're doing this, is because these teams sit and they do deep co-design together. It's not just one company maybe providing some APIs to a different company about how these might look. We're actually doing deep co-design. One of the reasons I went to Intel is because they wanted software to be the fourth pillar in this. So it isn't just about these three technologies, it's about software being part of that. So co-design is certainly an overused term. We talked a lot about it, multiple workshops over the last decade in DOE. But co-design is true even within a software stack, right? So when you take a look at making sure that the compiler team is sitting down with the MPI team, is sitting down with the libraries team, is sitting down with the operating system to make sure these all come together. And why is this so needed? One of the things that's happened over the last 2 decades is there's been a significant increase in the amount of components that exist, right? And these components lead to the potential for more and more incompatibilities. So we need, and to handle this and to handle the addition of all of these new components coming in, we also need the capability to continuously test and integrate and make sure that when we bring in a new version of a library or the next release of MPI, that they fit with all the rest of our stack. So those are a lot of technical reasons. One of the things we found as we did an ecosystem study is that fewer and fewer organizations, be them customers, national labs, academic institutions, or our vendor partners, OEMs, were able to stand up this increasingly complex stack. So that was meaning fewer and fewer options were being available. And furthermore, of the ones that were able to do it, an increasing amount of time was going into just getting the stack stood up, rather than actually focusing on what the mission needs were. So that led to Supercomputing 2015, when Intel, with a series of partners, about 40 different partners, stood up and introduced this notion and announced the intent to launch OpenHPC. There's lots of different aspects of OpenHPC that I could talk about. I want to focus on just a couple. First of all, let me just define what it is. OpenHPC is a cohesive and comprehensive system software stack that you can run your cluster all the way up to your supercomputer with. And just as a quick survey, let me get a sense of how many people have heard of OpenHPC. All right, so this is great, because more and more as I talk, more and more people are familiar with it. So I'll go through then this a little bit quicker, since a lot of you are familiar with it. But one of the things we wanted to do really was to simplify the complexity installation of doing this. If you're familiar with OpenHPC, you're familiar with that. We wanted to provide a place. There's a lot of open community work that goes on, right, across computer science, and we wanted to provide a place where that work could be focused on HPC. For the folks who aren't aware of it, it was set up to be announced set up with the intent to announce in Supercomputing 2015. The technical steering committee got underway last June. There's been some meetings at ISC last June, again at Supercomputing, and there's one coming up this coming ISC. So a lot of these slides, I should note, they come from OpenHPC. Carl Schultz, who was at TAC and who is a project leader, provided me with a set of materials. So this is in the words of the community, so to speak. These are slides that were taken from OpenHPC and their mission, right? And it effectively iterates some of the things that I just recently, seems to go in and out, sorry. Some of the things that I just talked about, and that includes, the amount of time that it takes to do this, and the time that it takes to continually, do this testing and integration and debug. So what they're, again, just in their words, what OpenHPC is doing is providing a set of prepackaged components. It's leveraging standard delivery models. It's allowing the community to have recipes that they're comfortable and familiar with, and it's providing a test and integration vehicle. One of the things that I really like to highlight, my background is, for folks who know me, is from the research side. And if you think about how we as a computer science research HPC community used to interact, is we'd write some papers and we'd come together at Supercomputing, we'd discuss those ideas, and then we'd go back. It was hard previously to take ideas that came out of a particular research group and try them out. one of the things that I'm very hopeful about with OpenHPC is it will allow that. As more and more members contribute code to OpenHPC, we'll have this opportunity to not only understand, academically what other people are doing and maybe apply it to our work, but also to take their code and apply it. And again, in the words of the OpenHPC, this is what their mission is: to provide this reference collection of open source HPC software and to enable the best practices that are going out there in a community. It's really a place where folks who understand how to do this can come together and other people can leverage a lot of this replicative and duplicative work that needs to happen. As I mentioned, there's 30 members. Here is the list of them. And I just thought I would kind of give the audience a sense of the interest. So this is from when we announced the intention to launch this at 0. There were obviously 0 visitors at that point. At supercomputing, there was a quick spike. And just recently, in March, they released OpenHPC released 1.3, and you can see the increased number of visitors. So a very positive and encouraging trend. The other thing that I think is very encouraging, and I interact with Carl fairly frequently to get a sense of what's going on, is there's a lot of interest from the community in terms of contributing new components. So let's talk a little bit then about what the structure of this is, what we are trying to do from a technical perspective. This here is an architectural diagram of the entire stack that you need to run. And one of the things I do want to point out is that applications really are the most important part of this. So I don't mean to give them just a small bar there, but that is why we build supercomputers, and that's why myself and my team in OpenHPC exists, is to enable the science, right? And so one of the key things, there were actually 2 tensions when we thought about how we were going to put together this stack. I would be interested to hear, but from an application or an ISV perspective, I think if there was just a single stack that ran across all different possible hardware offerings, it would be an ideal world. There wouldn't be any of those porting problems. There would still, of course, be performance portability problems, right, because there's different underlying architectures. So one of the things that we wanted to accomplish with OpenHPC, oh, I see this, I flipped over to IntelliHPC Orchestrator. I'll describe what that is in a second, but the stack architecture is similar. One of the things what we wanted to accomplish is to have a common and consistent northbound or API interfaced application, so that regardless of whether you're using OpenHPC or any of the products that OEMs came out with, you would just be able to run. But we recognize that individual sites, national labs, or OEMs want to be able to provide their own customization and differentiation. So we componentize this thing and define clear modular boundaries between the individual components so that as on a case-by-case basis, as needed, these components can be replaced. So again, this is from OpenHPC. This is their most recent release, and I just want to make a little bit more concrete in terms of what the instantiations of each of these components are. I won't spend a lot of time reading through them. It's effectively a curation of a lot of existing open source projects that are already out there, pulling it together into a unified and cohesive whole and providing that out. Quick question?
So one of the challenges I think in this area is that every site that you deal with typically has their own set of preferred tools. They've got their own file systems, their preferred system management. I mean, it's something that we at Cray struggle with, right? Because we want to provide a stack that everybody can use, but there's these preferences that aren't necessarily technical decisions. They're long-standing preferences. Do you think the OpenHPC, but if you start supporting multiple options, all of a sudden the validation and integration efforts explode. Do you think the OpenHPC community is equipped to make those sorts of trade-offs and choices?
Right. So just I'll just repeat the question for the folks who didn't hear it. If you take a look at a lot of the different community users of the software stack, a lot of them have their own specialized, be it libraries or MPI or different resource managers. And if you include all of these into OpenHPC, that's going to explode the validation space, which is an absolutely true observation. So the way the community is attempting to deal with this is just true to any open source community. For folks who are interested in contributing to this space, If they want to bring in a new, say, a new library, or they want to bring in a new resource manager, or as a concrete example, they want to bring in a new provisioner, such as XCAT, what we're looking for them is to not just say, oh, I'm interested in seeing that included, but to step up and help do the integration, and to also help do the testing and the validation. In the end, as more are added, it will become an exponential validation problem, and certainly you will not be able to test every option with every other option. And the technical steering committee is in the process of figuring out how to address that. Okay, so I think there's folks are definitely familiar with the open source model, and there's tremendous value to having such a capability exist where people can contribute freely. But equally, there are some, and there are probably some people who are sitting here, be it either from national labs or from companies whose procurement process don't allow them to use open source, that want to have the capability of having a supported stack. So at Supercomputing this last November, Intel announced that what we would be providing is we would be taking in OpenHPC, and we would be providing a supported stack on top of that called Intel HPC Orchestrator. So this shows roughly the whole flow. Again, as I mentioned, OpenHPC is garnered from a whole series, effectively, of curating a lot of open source projects. Those go into OpenHPC, and either OEMs or universities can directly take OpenHPC. And what we did is we internally tested it, did additional validation testing, did some scale testing, and we're providing it out through our OEMs as a supported offering. So if perhaps an analogous model for people who are familiar with operating systems, this is very familiar. This is very similar to CentOS and Red Hat, right? Anybody can go out there, they can use CentOS, they can freely use it. If they want to get support, they provide Red Hat. They get it through Red Hat. And what Red Hat does to be able to provide that support is they do a lot of additional validation testing. I personally think that this, granted a slightly biased view, but I personally think that this strengthens the open community because it now really broadens the scope at which OpenHPC can impact the community. So let me say a little bit more then about where we're going with Orchestrator. It is our intent to continue to contribute very actively to OpenHPC. Our intent behind Orchestrator really is to grab OpenHPC at various points and provide it as a support, just like CentOS and Red Hat are coupled. We're moving in we see the space divided into roughly 3 tiers. One of them is the high-end tier, think for capability class machines, like Titan that was mentioned before, Sequoia, Mira in this current generation, Summit, Sierra, Aurora in the coming generations. And this is the top tier, which we announced that Supercomputing would be branded custom. And Intel is currently undergoing a lot of internal development efforts that we will contribute to OpenHPC to help the stack scale more. So whether that's in enhancing the provisioners, whether it's in providing hierarchical mechanisms for doing resource management, or doing the underlying systems management, or monitoring, we are going to not only do those internally, but we will provide a lot of those base capabilities back. And we are also working on, again, a separate tier called Turnkey, which is an entry-level solution. This is, I think, also equally important. This goes to this ROI and being able to really bring HPC out to the broad community, and that is you want an organization that doesn't have a staff of system administrators who are going to customize your stack to be able to open up your box, and just like you open up a Mac and it doesn't ask you for the network topology and how many nodes in a configuration file, it asks you what the name is. The notion behind Turnkey is you open up your HPC box and you have an HPC application. I should say one more thing on this slide that's really important. The national government as well as individual vendors make lots of investments in high-end HPC. I think we've seen that through some of the numbers that Earl and Steve showed earlier on. One of the things, and again, I mentioned one of my carrots to going to Intel was to be able to drive this overall co-design, of which software was the 4th pillar. But the second one was this notion of trying to figure out a methodology by which we could leverage a lot of this investment that's made at the high end to have value, to bring value and have impact across the whole stack. So if you take a look at this figure, you'll see that, and I'm trying to push the technical teams, the internal technical teams, to making this common core be at least 80%. And I always get picked on for having this unattainable vision, but I think having lofty goals is a good thing. So if you envision having the majority of this stack be common, and leveraging the work that investments that the national governments make in the high end, and then being able to apply that across the stack will have a lot of value. It would also go the other way. I don't mean to say that. So if you think about some of the things you need to do down here, right, you need to have sort of autonomic node discovery and things like that. It's things at the high end that you have a system administrator who doesn't necessarily think twice about opening up an editor and putting in the IP. I mean, maybe they grumble a little bit, but they know how to do it. They have that expertise. But I'm sure they would be happy if there was something that autonomically went around. So I really see this flowing in both directions. So then let me just finish by saying that a lot of the trends, and it isn't just the ones that I identified at the beginning of the talk, Steve, Earl, and lots of the other people throughout previous presentations have talked about some of these challenges that we're seeing about managing them. It drove this need to have a stack to remove a lot of this replicative and duplicative work that was going on, and that really was the genesis behind OpenHPC. The reason that we, Intel, wanted to, and one of the things that I should have explicitly mentioned, because I always get asked, so I'm sure I'll head off at least a question, and that is, it is now, for the people who don't know, it is now a Linux Foundation organization. It was since the announcement at Supercomputing 2015, and the intent is to be entirely vendor neutral. In fact, ARM has, at Supercomputing 16, announced that they are actively contributing to it, and they had a prototype version of OpenHPC up and running and are continuing to be active in that space. So again, putting my research hat on, it really does facilitate this collaboration across groups. But perhaps most importantly for the ecosystem, it allows a greater efficiency. It means that a lot of the work that people across different customer organizations or across different OEMs we're doing again and again that really doesn't provide any value is now able to be done in a single place and leveraged. Intel is providing now a supported product based on OpenHPC. As we announced that SC16 will eventually drive it to 3 different SKUs. And I think one of the most encouraging things, and that was why, if you want to call it data, I showed that data chart about the increasing visitors to it. And that's not only is it increased visitors, but the scope, if you take a look at the number of countries that are taking a look at it, as well as just the overall hits that you're seeing and the downloads, all of those are increasing. So I'm very encouraged not only by the increased use, but the increased contributions. So with that, I've still got 2 minutes left, plus 5 for questions. Happy to take additional questions beyond the one Kelly asked.
Just have a simple question. How do you compare OpenHPC to Bright Software?
So yeah, that's a good question. So Bright Software offers a management capability. They are a tightly integrated and sort of monolithic stack. I think they have a good offering. OpenHPC is a modular stack. So if you wanted to pick up Bright Computing, but for some odd reason you just absolutely needed to use XCAT or something like that, right? Because that's what your users were telling you about. That's a pretty difficult challenge with them. Bright is obviously a proprietary offering, and OpenHPC is open source. So those are the 2 primary differences. I will comment, though, a little bit more about the monolithic and proprietary. So, I've heard it argued that, and sometimes when I've given this presentation, I've heard concerns, especially from supercomputer users, that, well, you're going to have all these different components out there. There's going to be lots of contributions. You're going to have 5 different resource managers. You have 3 different provisioners. How are you going to, what does that mean for me as an individual user? And the thing I want to point out is that does not preclude a deeply and tightly integrated stack, right? So even though there's going to be lots of choices in the open community, not only will we, through Intel HPC Orchestrator, but also other OEMs, can make a thoughtful selection of those components and provide a deeply integrated stack in a manner equivalent to kind of what you might think Bright does.
Bob, question. You talked about this being designed also to help smaller organizations that may be newer to HPC, and there's some choices here. Is anything being done or going to be done to help people make those choices who aren't so proficient in stack understanding?
So let me just see if I understand the question. So for maybe organizations that don't have a set of expert HPC system administrators, right, and they want to know what to run. So I don't want to, and Sunny maybe will be able to address this. He's on the board of OpenHPC. OpenHPC really is going to be an open community where people can come and contribute. I think they are coming up with a set of best practices. We will for sure in Intel HPC Orchestrator, and I expect our OEMs also to come up with, to work with individual either customers or classes of customers to say, okay, if you're in the oil and gas industry, this is how you would want to put together the stack, and these are your best choices of components. And certainly for ISVs, for that low end, for the turnkey space, we will come up with the term we're using as appliances. So we will come up with a very thoughtful selection that exactly matches it. But maybe, Sunny, do you want to speak to OpenHPC in general?
I'll just add a few comments, Bob. I think, I'll say this later, HPE is a premium member and certainly supports all the efforts of OpenHPC and believes in building on that stack. And by the way, we're very appreciative of the work that Intel has done to get OpenHPC to the point where it is. In response to the question, I think, as I see it, the work of the Technical Steering Committee has really been focused on establishing a base environment and common APIs and a common application base. We've also recognized, however, in doing that in many cases, it still requires a certain amount of expertise to build the stack. That you need to be too expert, and folks that have good knowledge in Linux system administration and HPC stacks can do it. So there's been conversations in the Technical Steering Committee, you may have been part of some of those, Bob, recently, that we really recognize that we have two different user groups, which I think is what you're speaking to, Steve. There are more expert users that can still take advantage of OpenHPC and the integration and validation that it offers, and novice users, new users to HPC that we need to address, helping them make choices and helping them make the stack easier to build and easier to use.
A question over there?
So perhaps are you doing too much? I mean, you talk about accommodating new frameworks such as AI and Python and analytics, and shouldn't you be looking at the container orchestration instead?
So yeah, so there's a couple directions that we're taking along those lines. For supercomputing, we actually did a proof of concept for both OpenHPC and Orchestrator with cloud, where we figured out a way to bring, in a simple manner, but as a demo point and to generate conversation, how to bring cloud and HPC together. We also took a look at how to run OpenHPC in a container and also on something like Microsoft's Azure. And we are also working to bring in ML and DL frameworks into OpenHPC. So we are working, I don't know whether those are the only three, but those are certainly the three burgeoning new efforts in HPC, containers, packaging capability.
But you can't detail that large cost, right?
What's that?
I mean, OpenHPC won't be detail that large cost. There's so much more effort being put in container orchestration.
I'm sorry, I didn't quite.
You're saying you're thinking of putting new frameworks into the OpenHPC stack, but the new frameworks are, getting a lot more development effort than OpenHPC will ever get.
Yeah, OpenHPC. You shouldn't view OpenHPC as a development. I'm sure we're going to allow the capability for new tools to be developed, but we're not looking at OpenHPC as a development effort. We're looking at OpenHPC as a curation of other open projects that have a lot of active development, right? I mean, if you take any of those projects that I listed on the left, whether it's Slurm or Werewolf or Lustre or certainly Linux or any of those, right? OpenHPC is not trying to develop in those spaces, and we will take the same fundamental thinking in terms of when it comes to picking up whether it's TensorFlow or Caffe or any of these machine learning. The value that OpenHPC will bring is we will show how to integrate these in a seamless manner and allow, if you want to combine HPC with the machine learning, a platform on top of which you can stand. I don't know if Sunny wants to make any additional comments, but it's not OpenHPC's intent to do development into each of these individual components. Yeah.
I guess my comment on that would be, one of the views that we talk about is that the HPC stack should get simpler, and all of these new workflows should move into containers. Is OpenHPC
So we
in
are.
that direction or not?
So we are certainly taking a look at containers as a possible augmentation. Yeah, so the question was, the stack's getting more complex, like I observed at the beginning, absolutely. And containers are one way of helping some class of users reduce the complexity of the stack. And yes, containers are absolutely compatible with OpenHPC. I actually am aware of a few groups that are taking a look at trying to bring those together. I think Sunny made a great observation that it's not going to be a one-size-fits-all model. For some, that's going to be a really great fit, and they'll really leverage it. There's other users who don't want containers, actually, right? There's other users who really want to be able to get down and tweak and twiddle the bits and make the customization. So I think containers will be an augmentation, not a replacement of where we're going.
You had in your slide, Bob, that singularity is already been improved or inclusion into distributions. So yes, I would agree. Containers and other interfaces that make the stack more interoperable are.
Yeah, absolutely.
Yeah, I mean, I was going to plug the containers anyway, but I mean, I just got to say, I think to say that you're not doing development is naive at best, because you're going to end up with nothing but a whole bunch of glue code that you're calling scripts to make things work together. And to actually adopt the open source perspective, you actually need to go into those products and improve them in a way that actually makes them work more interoperably, not write a lot of external glue that puts them together. So, and I know that's been the biggest criticism of OpenHPC so far, is that they've taken this curation approach, but I'm telling you, it's naive to say you're not going to do development in those projects.
Yeah, so that's a fair comment. The way that I would address that, so another way of saying that is to get this tight integration that we're hoping for. And so we actually have an effort that we're going to provide to the open community. It's something called the DAI. We haven't talked a lot about it, but it just stands for Data Access Interface. It's a way to get all of these components to more tightly and seamlessly interact with each other, because what you're saying is absolutely true. Today, on a case-by-case basis, it's true that maybe Slurm has figured out how to request something from Werewolf or vice versa, but it's absolutely true that resource managers don't know how to request things from provisioners, and they don't actually know how to get information from the monitoring systems that exist out there. So what I meant by that we aren't going to be doing development in OpenHPC, and I think there will be potential tracks, is what we're hoping to do is to get these communities to realize the value of this and to try to do development within their own pieces to be part of this more tightly integrated framework.
Most of the developers for those tools don't have environments like that. That's the biggest problem. The people that have the environments don't have the open source skill set to do that work. The people that are doing the open source skill set don't have the environments in the first place to actually do the integration.
So I think in principle we're agreeing, and in terms of how we're going to get this accomplished, maybe Sunny, I, and you, this would be great input to get back to the community.
Are you Ryan? Are you signing up?
Another question?
So yeah, I just want to reflect on what was said here. We have evaluated at Red Hat the possibility of integrating and working with the OpenHPC community, and pretty much have determined that containers is probably the only way forward from our existing development model and support model. So that's kind of very reflective of what had been said, so I appreciate people making comments on that. And also on the last gentleman's point, I think the alignment of these two domains where you have developers with the skill sets and then the lack of the environments, what would be ideal for the OpenHPC, and I'm not necessarily saying HPC Orchestrator should be part of it, is to have the ability to develop and compose containers on the fly for the specific environments and ship the whole thing directly. And so that takes away a lot of complexity and gives you a chance to actually stand up the environment almost instantaneously. So all you have to do is figure out what your underlying architecture is, and soon enough we probably will have containers that are architecture independent, right? And have the agreed upon container standard, for which we're working on pretty heavily. I know there's some others from the community, not necessarily HPC community, but general community, open source community, folks who have been working and contributing to that.
Okay, well, yeah, appreciate the comments, and yeah, we're aligned with them. Thanks.